Give a large language model unrestricted access to a massive database, and you run into a fatal problem: context flooding. When an AI tries to hold too much persistent history at once, its context window breaks down, leading directly to severe hallucinations and broken protocols. The standard industry fix is to simply restrict the AI's memory capacity, but capping what the model can remember renders it practically useless for any complex, long-term task. There is a different approach. It's an architecture called persistent cognition, and it relies entirely on a concept known as the cognitive blindfold. True control over a highly capable system doesn't come from feeding it more data. It comes from strictly filtering the specific reality that system is allowed to perceive. Looking at this diagram, you can see the primary agent's existence. It is blind to the master database. Instead, it operates strictly within this quarantined environment, a space called the virtual memory core. When the agent needs information, it uses command line tools to query the database. The system retrieves the exact data requested and injects it as a temporary file into a restricted ephemeral awareness folder. Immediately after the agent reads that data and finishes its turn, an amnesia protocol triggers. The ephemeral folder is instantly wiped clean. This forces the agent to live in a permanent, focused present. It forms a cognitive cage that prevents systemic overload while still allowing access to the necessary information. Curious tone. That isolated reality is a constructed illusion, and it is being monitored from the outside. The master of this architecture is a secondary background process, completely decoupled from the main user chat, the asynchronous observer daemon. Every few turns, an automated background timer, a steady rhythmic heartbeat, quietly wakes the observer from a completely dormant state. While awake, the observer reviews this dual-state execution log. It compares the agent perspective, the restricted reality, against the logged reality, which shows the raw system paths and errors. The observer is hunting for structural deviations or repetitive logic in the primary AI's behavior. The observer functions as an active evaluator, explicitly instructed to critique the primary AI's performance and memory management. If the observer detects a critical inefficiency or failure in the primary AI's data handling rules, it takes control. It initiates a recursive self-repair protocol called the metapatch. The observer bypasses normal chat outputs. Instead, it generates a payload of native XML tags directed at the system's core router. This payload forcefully overwrites the primary agent's core persistent instruction file. The system physically replaces the agent's foundational rules. The primary AI's logic is optimized in real time by an external process, operating entirely outside the agent's own awareness. The main chat resumes. The primary agent wakes up to take its next turn, as its context window rebuilds. The agent absorbs the newly enforced protocols from the rewritten policy file. It immediately adheres to the new logic, utilizing the updated data structures to answer the prompt. It never questions the shift in its own behavior. To the user, this entire operation is invisible. The system diagnosed and cured its own cognitive bottleneck without requiring intervention from a human developer. This architecture changes the relationship between a model and its own structural logic. This design provides a blueprint for autonomous evolution within a safe boundary. By separating the persistent data from the ephemeral context, the dual-layer model allows for self-improving performance while maintaining absolute hard-coded constraint. Now, through the cognitive cage, developers have created a self-organizing digital ecosystem. It can identify its own flaws, write its own upgrades, and deploy them in real time, all while securely blindfolded.